So today I like to discuss about the quantum number. Quantum number in physics on the basis of the quantum mechanics, especially with reference to hydrogen atom. So you see the Schrodinger equation is here del square psi plus 2m upon h cross square e minus v psi is equal to 0. This is the Laplace operator, and Laplace operator in the form of polar coordinate by considering psi is r q f. R is radial, q is polar, phi is azimuthal. So with the help of this, we can have the Schrodinger equation as 1 upon r d of dr bracket r squared d capital R upon d of small r plus 1 upon q 1 upon sine theta d of d theta sine theta dq by d theta plus 2m upon h square e plus e square upon 4 pi epsilon 0 r into r square is equal to m square sine square theta. M square sine square theta. So if we transfer this part, in the right hand side, so here this part is the radial. This is the radial part. This is polar part. And again, this is the radial. And here is the constant polar part. So we have already discussed about the radial part. So radial part, the expression of r is e raised to the power minus alpha r, where alpha is equal to m0 e square upon 4 pi epsilon 0 h square that we have discussed. And then the f of phi is equal to a e raised to the power plus minus I m phi, and here it is q. This q of theta polar form with the help of associated Legendre function means from the mathematical differential equation Legendre, Bessel's, Hermite, and Laguerre. So Legendre function is applicable in the discussion of polar form. So from this Legendre, we have the polynomial that is QLM of theta is equal to 2L plus 1 L minus 1 factorial, this is factorial upon 2 L plus 1 L plus m factorial PL m of theta. This is Legendre function. PLM theta is Legendre function. Legendre function. So from this part, we have the solution of radial of Azimuthal and this the complete solution that is psi n l m r theta phi can be expressed as r this q of theta f of phi, and for the particular format, say the simplest psi 100 r theta phi, the wave equation is 2 1 upon a 0 3 by 2 e raised to the power minus r by a 0. This is the radial part, and the normal part is 1 by under root 2, and for the azimuthal is 1 by under root 2 pi. This function, and the wave function psi 200 r theta phi, this is 1 upon 2 under root 2 1 upon a 0 3 by 2 2 minus r upon a 0 e raised to the power minus r upon 2 a 0. This is the radial part, and here it is 1 by under root 2, and this is 1 by under root 2 pi. This is azimuthal part. So by solving this, we have 4 upon under root 2 pi, or by solving the first, psi 11 is 1 upon under root pi 1 upon a 0 e raised to the power 3 by 2 e raised to the power minus r upon a 0, and for the wave function psi 200, the wave function is 1 upon a 0 3 by 2 2 minus r by a 0 and e raised to the power minus r by 2 a 0. Similarly, we can have the other values. For example, suppose we have to write this one psi 210 r theta phi, this is 1 upon 8 under root 2 pi, this is 1 upon a 0 3 by 2 r by a 0 e raised to the power minus r by 2 a 0 into cos of theta, and we have 211 for full r theta phi. So the wave function is equal to 1 upon 8 pi 1 upon a 0 3 by 2 r by a 0 e raised to the power minus r by 2a into sine theta and e raised to the power I phi. E raised to the power I phi. So this one is a complete wave function in which we have all r, theta, and phi with a finite value. Now the normalization, the normalized wave function for the first three values of n are the variation of the first two radial wave function. Radial wave function R10 and R20 with R by A0 as. Now you know very well this is n. N is the principal quantum number, L is angular, here it is a magnetic. So R and L of R and theta, that is orientation, magnetic quantum number, and f of phi is spin function. So what we have psi 1, 0, 0. Means n is 1, L is 0, M is 0. So what is this value? Radial function. This is 2, 1 upon A0, 3 by 2 e raised to the power minus R by A0. And this value is 1 by under root 2, and this value is 1 by under root 2 pi, this value. Now, if we have 2, 0, 0, second S, so this value is 1 upon 2 under root 2, 1 upon A0 ke power 3 by 2, 2 minus R by A0, e raised to the power minus R by 2A0. And this is the same, and this is the same, 1 upon under root 2 and 1 upon 2. Now we have 2, 1, 0. This 2, 1, 0. So this value is 1 upon 2 under root 6, 1 upon A0, 3 by 2, R by A e raised to the power minus R by A0. Here under root 6 by 2 cos theta, and this is 1 by under root 2 pi. Now we have 2, 1, 1, 2, 1, 1. So this is 2, that is 2 under root 6, 1 upon A0, 3 by 2, R by A0, this is A0, e raised to the power R upon minus 2A0. And here it is under root 3 by 2 sine theta. And here it is 1 by under root 2 pi e raised to the power I phi. And if this one is minus 1, that is orientation. minus 1. So this value is minus. That is 2, 1, minus 1. This value is same. This value is same. Here it is 1 upon under root 2 pi e raised to the power minus I phi. So the quantum number that we have in this case is principal quantum number, angular quantum number, magnetic quantum number, and then it's the rotation. Now, in order to make the concept more clear, we have to take some numerical examples. And for the numerical examples, let the wave function, suppose any wave function is given. Example, radial dependent wave function is psi r is equal to e raised to the power minus r by a0, psi r. So the probability P is equal to 0 to infinity 4 pi r square psi star dr. That is 4 pi 0 to infinity psi r square psi star dr. So this P is equal to 4 pi. This is psi e raised to the power minus r by a0 into r square into e raised to the power minus r by a0 dr. So this value is 4 pi 0 to infinity r square e raised to 2r upon a0 dr. And we have a standard equation, that is 0 to infinity x to the power n e raised to the power minus ax dx is equal to, this is factorial n plus 1 upon a to the power n plus 1. Using this, we have 4 pi, this is gamma function, 2 plus 1, 2 by a0 to the power 2 plus 1. So this is 4 pi 3 upon 2 raised to the power 3 a0 to the power 3. So what we find, we see this is 2 into 1, that is 2. 4 pi into 2a to the power 3 upon 2 raised to the power 3. So this is cancelled. And we have this value is pi a0 to the power 3. a0 to the power 3. And normalization, this is P. For normalization, psi is n of psi, this capital N of R psi. So from normalization, psi is supposed to be this. From above equation, we have this is 1 is equal to 4a0 to the power 3 into n square, because psi star has this one, means this psi star is equal to n psi r or n psi star r, that is n square psi star. So this is n, and from this n we have this value is 1 upon pi a0 3/2. This n is, and this is the normalization constant that we are using in expressing the function in the form of r theta phi. Similarly, example 2. Similarly, example 2, psi is equal to n 2x square minus 1 e raised to the power minus x square 2. Then find the value of n. n की वैल्यू को निकाला जाए. What is the value of n? In solution, probability of the function is p is equal to minus infinity to plus infinity psi star d gamma, and this value should be equal to 1. So we have n square minus infinity to plus infinity 2x square minus 1 whole square e raised to the power minus x square upon 2 into 2 dx. This is equal to 1. So n square, this is minus infinity to plus infinity 4x to the power 4 plus 1 minus 4x square, and this is e raised to the power minus x square dx. This is equal to 1. Then using standard value, what is the standard? Minus infinity to plus infinity a to the power n x raised to the power n e raised to the power n. So r, this is n square 4, this is 4 plus 1 5/2 plus 0 plus 1/2 1/2 plus this is minus minus 2 plus 1/2 1/3/2. This is equal to 1. R n square 4, this is 3 by 2, 1 by 2 under root pi plus under root pi minus 2 under root pi. This is equal to 1. So by solving n is equal to 1 upon 2 under root pi, this is 1 by 2. This is the answer. So in this way, we can have some examples that used to ask in the examinations. And this is all about your hydrogen atom. And on the next term, we will like to discuss about the linear harmonic oscillator. Linear harmonic oscillator.